Welcome, everyone. I am Dr. Zycon. I am an associate professor in the Department of Mathematics and Statistics at Hazard University. In this lecture series, I will introduce fundamental concepts of probability and in a clear and practical way. My goal is to build a strong understanding of statistical ideas that are widely used in science, engineering, business, and everyday decision-making. In this lecture, we will study the concept of probability of a simple event. Probability helps us measure how likely an event is to occur. Many situations in daily life involve uncertainty. For example, when we toss a coin, roll a die, or draw a card from a deck, we cannot predict the exact outcome in advance. Probability provides a mathematical way to describe such uncertainty and measure the likelihood of different outcomes. In this lecture, we will first understand random experiments in sample spaces, and then learn how to compute the probability of a simple event. To begin our discussion, we first need to understand what we mean by a random experiment. A random experiment is an experiment whose outcome cannot be predicted with certainty before it is performed. Even though we cannot know the exact result beforehand, we do know all possible outcomes that may occur. Some common examples of random experiments include tossing a coin, rolling a die, drawing a card from a deck, or selecting a student randomly from a class. Each time we perform the experiment, the result may be different, and this uncertainty is what makes the experiment random. To better understand random experiments, let's look at some common examples. Let us consider some examples of random experiments. When we toss a coin, the result may be either heads or tails. We cannot predict which one will occur. When we roll a die, the result may be any number from 1 to 6. When we draw a card from a deck, the card selected is uncertain until the draw occurs. Similarly, selecting a student randomly from a class means that any student may be chosen. These examples illustrate the idea that although the result is uncertain, the set of possible outcomes is known. The set of all these possible outcomes is called the sample space, which we will define next. The sample space is a set of all possible outcomes of a random experiment. We usually denote the sample space by the letter S. For example, when we toss a coin once, the sample space contains 2 outcomes, heads and tails. When we roll a die, the sample space contains 6 outcomes, 1, 2, 3, 4, 5, and 6. The sample space represents every possible result that could occur in the experiment. Once we know the sample space, we can define specific outcomes or groups of outcomes that interest us, which are called events. An event is any subset of the sample space. If we denote an event by the letter A, then event A is a subset of the sample space S. In simple words, an event is a collection of outcomes that satisfy a certain condition. For example, when rolling a die, the sample space contains the numbers 1 through 6. If we define event A as getting an even number, then the event consists of the outcomes 2, 4, and 6. Thus, an event represents a particular situation that we want to study. After defining events, the next step is to measure how likely an event is to occur, which leads us to the concept of probability. When all outcomes of an experiment are equally likely, we can calculate probability using a simple formula. The probability of event A equals the number of outcomes in event A divided by the total number of outcomes in the sample space. In mathematical terms, we say P of A equals N divided by N. Here, N represents the number of favorable outcomes, and N represents the total number of possible outcomes. This formula works only when each outcome has the same chance of occurring. Let us now apply this formula to some simple examples to see how probability is calculated in practice. Let us consider the example of tossing a fair coin once. The sample space contains 2 outcomes, heads and tails. Suppose event A represents getting ahead. There is 1 favorable outcome for event A, and there are 2 possible outcomes in total. Therefore, the probability of event A is 1 divided by 2. This means there is a 50% chance of getting ahead when tossing a fair coin. Next, we will apply the same idea to another random experiment involving a die. Now consider rolling a standard 6-sided die. The sample space contains 6 outcomes, 1, 2, 3, 4, 5, and 6. Let event A represent getting an even number. The even numbers are 2, 4, and 6. So there are 3 favorable outcomes out of 6 possible outcomes. The probability of event A equals 3 divided by 6, which simplifies to 1/2. This means the probability of getting an even number is 50%. Let us now consider another event from the same experiment. Again, consider rolling a die. Let event A represent getting a number less than 4. The numbers less than 4 are 1, 2, and 3. Thus, there are 3 favorable outcomes. Since the sample space contains 6 outcomes, the probability of event A equals 3 divided by 6. This simplifies to 1/2. Therefore, the probability of obtaining a number less than 4 is 50%. Finally, we will look at another example involving selection from a deck of cards. Consider selecting a card randomly from a standard deck of 52 cards. Suppose event A represents drawing a heart. In a standard deck, there are 13 hearts. Therefore, the number of favorable outcomes is 13, and the total number of possible outcomes is 52. The probability of event A equals 13 divided by 52. This simplifies to 1 divided by 4. This means there's a 25% chance of drawing a heart from the deck. This example concludes our introduction to computing probabilities for simple events. Thank you for watching. Do not forget to subscribe to this channel for understanding probability and associated concepts.